All right, gentlemen, good evening. I've been behind the camera the last 2 or 3 times, so I haven't really said anything, or y'all don't know anything about me. But my name's Scott, and I am, like Vaughn said, a certified permaculturalist. That means I'm accredited to teach this course to other people. Also, a certified natural builder, which we're going to be talking about a little bit tonight. I know we talked about it last time, but I just wanted to go over a couple of the points and make sure y'all understand some of the different methods. I'll give you a little more history. I've been doing landscaping for probably 25 years. First job I ever had, and I kept doing it. I like it, you know, it's good physical labor. It's also creative and allows you to see instant gratification. You know, when you finish a project, you start it, finish it, you know, helps it all come together quite nicely. And it's also meditative, so it helps bring peace in my life, you know, when I work with the dirt and plants and stuff. I went to college and got an education degree, so I'm also a certified teacher, where I teach elementary and early childhood education. I always thought that would be a great place to target individuals at an early age and then help to shape them into prosperous, productive members of society. This other stuff, I just been studying permaculture and natural building for about the last 15 years. I started a learning center in Costa Rica, and we still have the property over there, still have the learning center. I brought a book which I could pass around to show some of the work that I've done over the years, some of the pictures of Costa Rica, newspaper articles. We made a movie about surface and groundwater sources, and just continue to collaborate with other organizations to help bring awareness to this. Really, it's an art form. It's a science and an art. Permaculture is an integration of all the things that I just told you about my background. So anyway, I'll pass this book around and y'all can take a look at it. I also brought the Permaculture Designer's Manual, which is like the Bible of you know, the permaculture philosophy, and I'll pass that around too. It gets pretty scientific, but really it's pretty simple to understand. So today we're going to go over again natural building methods. All right, we talked about, I'm going to write them on the board so y'all can see what I'm talking about. Adobe and cob. We talked about straw bale, papercrete, or ferro cement. We talked about bamboo, rammed earth, or compressed block.
Scott,
Yes, sir.
Do you need another marker?
Yeah, I do, as a matter of fact. This thing's weak. Earth bags. Can y'all see any of this from back there? Wattle and daub. Cordwood. Earth ships, which is what Vaughn spoke about in great detail last time. This number 10 I had on the list is really not a natural building method, but it's alternative building method. Containers. I'll try to draw y'all some diagrams of these things. Container conversions. Thatch. All right. Thank you, sir. We got living structures. We have underground. And last, hybrids. All right, so adobe and cob. Y'all know what adobe is? Cob? It's clay, sand, straw, and poop. Okay. They use all these are mixed in certain proportions, which you really figure out what your consistency is and what you need in accordance with the kind of earth you have on site. You know, the kind of clay, the kind of sand. Mix it all together. You can feel the consistency of what you need, and usually it's like 1 to 1 to half to half. 1 clay, 1 sand, and this is a bucket I'm talking about, a 5-gallon bucket. 1 5-gallon bucket of clay, 1 of sand, half a bucket of straw, and a half a bucket of poop. Okay, like we're talking animal feces, cow poop, horse poop, any kind of stuff like that, which adds tensile strength because of the fibers inside of it. Mix it all up, and we have cob. Okay, adobe. You can also take that same material and put it into forms and make block. Okay, which would be adobe block. The cob, you pretty much just throw it on to your structure and press it in with your thumbs, okay, to create little pockets, which you can then add more layers to, and you just continually build up on that, which the last layer is typically like a lime-based plaster to help keep the surface waterproofed, because if you allow water to get on mud, on dirt, of course you're going to have mud and it's going to disintegrate and fall down. Okay, straw bale, pretty self-explanatory. Hay bales, straw bales. The way we would do that method would be typically to build a stick frame structure without the walls. Where your doors are, you build your lintel, your support systems, your corners, and then you fill in with straw bale. Okay, and run your stringers or whatever up the straw bale to secure it, and then cover it with cob or adobe or papercrete. Okay, papercrete is refuse material, trash, anything from phone books to pizza boxes to office paper, any kind of paper, magazines. I built one of these machines, a papercrete machine in Costa Rica. What it is a water tank, just a water collection tank like this. It's built up onto a rear differential of a car or truck. Okay, it's got you flip it up here. We got a lawnmower blade on the inside. Throw your paper right inside the hole here. Add water. Add a fraction of Portland cement, which is going to help bind it together. And as you go down the road, picking up, what I used to do was go down the road in town and stop at all the stores and pick up cardboard boxes, whatever they had, throw it in the back of this thing, go to the next one. As you drive, it mulches up the material. Then you've got a release mechanism back here on the back, which you let the material out. You know, you can use it as a slurry to stucco with. You can use it to build blocks out of. It's lightweight but very strong, and the best part about it is it's free. Okay.
And the insulation value.
And the insulation value is great as well. Bamboo, of course, we know what that is, and one of the advantages of bamboo is its rapid growth rate. It's a highly sustainable source of material. This stuff grows like weeds, you know.
It is.
It's in the grass family, but you can use that for multiple forms. You know, you can, do a lot of different methods with that. Rammed earth or compressed block is primarily just taking the earth, tamping it, to get all the air spaces out of it, making it a solid form, and of course then covering it with another material to keep it dry. Earth bags, polypropylene sacks, like feed sacks. Fill them full of gravel, sand, or earth, and use them like building blocks. Okay. It's another quick way to build a wall. I think the quickest way to do it is straw bale, because that's a lot of mass. It's pretty easy to handle, easy to stack. I mean, you can build a wall in, a couple of hours.
Like you would with sandbags. Like you would with sandbags.
Sandbags require a little more effort because you got to fill them up, and then same idea. Some of these earth bags, you can, like I say, just use regular feed sacks. You have to sew the end of them shut. Okay, we have like a sewing machine just specially made for earth sacks, because you don't want them popping open and leaking out, create a weak link in the structure. But in certain parts of, like in California, there was a guy out there who was real big on this earth bag method, and he started making the earth bags not just regular sack size, but making them like round like this. So you fill them up and then you just stack them like that. That way you have one solid piece. And they would do this, and this is what the structure would look like pretty much. Of course, you put your windows in and your door, but it looks sort of like an igloo.
Or an old-fashioned beehive.
Yeah, or a beehive. Wattle and daub. Very easy method, dating way back, ancient times. Again, you would typically have your corner post built. Then you would put some linear pieces here, bamboo or smaller saplings, okay, as your support structure. Then you would get green saplings, small bendable sticks, and interweave them in here, okay, until you fill that space up. And you would do it close together. All these, there wouldn't be any air gaps or anything in there. So after you do that, then again you go back here and you cover it with adobe, cob, papercrete, whatever to give you solid structure. Cordwood, as Vaughn mentioned last time, is taking pieces of logs, okay, and say this is a side view of your wall, okay? You stick the logs in this way, okay? Then you build in around it with chinking, just like a log home, but use again adobe or cob, I should say, to pack in around it. But all these do, you think of them as like a space filler, a large space filler. You can take small pieces like this and just continually do that. And it looks pretty cool too, because you have the ends of the log visible. That's a good method as well. Earth ships, I think y'all got a good understanding of that last time with Vaughn. That seems to be his favorite method, which I like the method too, because really earth ships to me are like a hybrid. It's taking all these methods and putting it to work in one piece, in one structure. You don't really have to just do this or just do this. It's about integrating all these aspects to build you a free home. And I think I remember last time somebody asked, why would you want to do this? Why would you want to build these kind of structures? Well, you can spend $150,000 and mortgage away your life to a bank or a private donor or whoever you can get the money from, but obviously you're going to be indebted that way. If you have a site with readily available resources, then you can practically build a house for free. And not only is that one of the key aspects, but it's also earth friendly. All this stuff that they've really brought onto the building market for the last 50, 60 years, in my opinion, is nonsensical. It doesn't make any sense. Manufactured goods require a lot of energy to make, to excavate the materials, then to convert it into a usable form, then to ship it halfway across the country. And then they're adding materials to it that pretty much make it toxic. I call these new homes toxic boxes, because everything in them is pretty much toxic. And as the life of the house progresses, they start to break down and leach those toxins into your living environment, which, your home is supposed to be where your heart is, not where your, cancer is.
That's like the treated lumber and stuff they be using.
Treated lumber, all
Like
that.
for termites and stuff like that.
Mm-hmm. The vinyl siding, polyvinyl chloride. That's what PVC siding is made of. All the PVC in the houses that the water runs through is a toxic chemical, is what it's made out of, or a cacophony or a mixture of toxic elements. And one of the laws of permaculture is the law of entropy, which means it's a universal law. Everything breaks down over time. Okay, with these kind of homes, when it breaks down, all you're going to be left with is a pile of biodegradable, compostable material. When you have these manufactured homes, you're going to be left with a pile of debris that leaches out toxins as it breaks down, takes up a lot of space, really is nothing but trash. But with the code system and the code enforcement that they've placed in just about every county across the United States at least, they've made it very hard to build these kind of structures. You really have to convince them, and it's hard to do that because they typically have one foot in the world of manufacturing these toxic materials and the other foot in enforcing the laws that would, you know, make it necessary for you to have to go out and buy it. Okay, buy these kind of manufactured goods. So it makes sense. All these manufactured goods make sense if you want to be in servitude, because you're always going to have to go outside of yourself to get the materials you need, and then they're going to break down quicker over you know, a length of time, and you're just going to have to go replace it. So it's a never-ending cycle. Okay, this kind of deal here, you can dig up a hole in the ground close to your house to get your dirt, and at the same time build a fish pond, you know, and cut your grass and make straw bales. Instead of throwing your trash away, make papercrete out of it. Bamboo, you know, creates, you know, it's aesthetically appealing to look at, but it's also can be used as a windbreak. You know, if you want to build a windbreak around your house or in front of your garden or whatever the case may be, you can do that and then trim it. And as you trim it, use those materials for aspects in your house or your garden. Okay, containers. What I'm talking about is shipping containers, okay? Like they use for shipping around all this nonsense I'm talking about. You know, when they get finished with these things, when they get rusted out a little bit or damaged, beat up a little bit from use, they just discard these things. You can get them for pretty cheap, and people use them as homes. Okay, you can stack them, you can put them next to one another, you could do, you know, stack them like this. I've seen people stack two here, another one on top, have a sliding door here, it slides open. They've got like a studio up here, 2 rooms down here, you know, which are heavily secure. If you put a good lock on them, nobody can break into those things. Put you a nice ventilation system in there and air conditioner. Run all your electrical wires, and pretty much have a fail-safe home for cheap. Thatch material, that's like you know, thatch roof, using plant material to interwoven together to make a fibrous roof. You can do the same thing for the walls. African, you know, what I think about, or what I see when I, you know, talk about thatch is African huts, you know, wigwam type deals, made out of materials that they have right there. Which, if you look back across the history of human evolution and civilization in general, most people use what they have. Okay, they don't go, if they live in South Carolina, they don't go to California to get a redwood tree, you know, to build a house out of it. They go get pine trees or whatever's growing in their backyard, I mean, because it makes sense. Living structures. Okay, this is pretty cool. If you've got vision and you've got time, you can actually plant, this is the ground, you can plant trees, okay, and manicure them. Say you and shrubbery. You can constantly, y'all know what topiary is, right? That's like, you know, these people that trim shrubbery and make them into different forms. Same thing. You plant trees, use those as your structural integrity, structural elements within the house. your shrubbery or smaller trees, continue to trim them. Next thing you know, you got a wall. You know, real simple. It continues to grow as a living structure. It's not outgassing toxic elements, and probably got some pretty good vibes, you know, in a structure like that. Underground. All right, underground, we can use these containers, bury them under the ground. That's always been a good method that I like, or a good idea. You know, like this farm we have in Costa Rica, I always said, okay, let's build this underground structure, bury a container, put grass on top, you know, make it invisible. Okay, that would be a good place to store all your food items, because, you know, I have this vision of when this system within the United States and globally, where we're dependent upon other people for our food sources. When we run out of gasoline, you can't transport food 2,000 miles across the country. The grocery stores shut down, food prices go up because everything's tied to gasoline, and hysteria breaks out, right? If you're smart enough to grow your own food and learn how to can it, this would be a good place to store it. So any mayhem ever break out or any problems, you know, that's safe underground in a cool environment, out of sight, out of mind, you know?
Bunker, in a war.
Like a war bunker, exactly. Okay, so hybrids are exactly what it says. It's a mixture of all these forms. Like I said, whatever you have at your site is what you would use. One of the basic building blocks or key elements of permaculture is observation. Okay, when you have a site, you're supposed to not do anything to it for a year, because you're supposed to watch the cycles of nature, watch how the sun, you know, moves, how the moon moves, how the wind blows, where your water runs. All of these elements you're supposed to watch and then work in conjunction with that. Okay, with our modern day mindset, what we are typically trained to do is go, all right, I want, see that spot over there? That's beautiful, I want to go live there. And then you go over there and then you just start tearing it up to make it exactly what you envision. Okay, instead of actually taking the time to think about it. And in doing that, we are going against the flow of nature, which then causes problem after problem after problem. Okay, it's so much better to work in harmony with nature and capture natural energy flows. That's what permaculture is all about. One of the other main ingredients or main elements of permaculture is what they call stacking functions. I'm going to briefly touch on this because this will lead us into Vaughn's discussion on the zones and sector analysis, which is a vital aspect of permaculture. So, stacking functions. They also call it multiple functions. Okay, one of the rules in permaculture is that everything that you do should serve three purposes. Okay, have three uses, at least three functions for all your actions within a permaculture design. And those actions have to be mutually beneficial to one another, or work in what's known as a symbiotic relationship. You know, what you do here will then help this aspect, and that aspect will help the next aspect. Next thing you know, you are working in harmony within your design. I'll give you an example of that. Okay, trees. All right, we all love trees. Okay, say we got a fruit tree. bring these branches down a little bit. All right, so can anyone tell me what 3 functions that a tree could serve within a living environment, your home or your farm?
Shade.
Shade, that's a good one. Shade, yes. Food.
Structure.
Oxygen.
Oxygen? Yeah, that's a great one. Can't live without it.
Living structure.
What is it?
Living structure.
I'm sorry, I
Building material, living structure.
Building material, yeah.
Or living structure, he was saying.
Okay, building material,
And aesthetics.
exactly. Aesthetics. Okay, good peaceful meditative area, you know. You sit underneath the tree, get some shade from the sun, eat an apple, daydream about how you're going to create your space, you know. Another reason that we could use, or another function that we could use, would be a windbreak. All right, say this is your house. Say you're getting heavy wind coming in here. Say you're trying to grow some grapevines up here, but they're getting, you know, beat up by this wind. Okay, the tree can help block that. Another function. I'll give you another example, which the tree example is always a good one, but like a hedge. Same thing, we can have fruit if it's a fruiting specimen. Privacy. And shelter for wildlife. Okay. One more example. A pond. We briefly mentioned that just a second ago when I was talking about the excavating materials for building a house. Okay. A pond. Does anybody know what you can do with a pond? What functions? What functions it could have?
Food, water, purification for
Food. Food being the fish, right?
Yeah.
You could also grow aquatic plants, which are edible.
Irrigation.
What's that?
Irrigation.
Irrigation. You could use it for irrigating your plants.
Natural air conditioning.
Natural air conditioner. AC. Also, you could use it for a heating source, because if you place it in, you know, proper proportion to your home, you can use it to reflect the sunlight into the house. It also stores heat, which would then be, you know, irradiated out and help warm an area that might be beneficial for certain types of plants you want to grow in maybe a colder environment. You know, you capture the heat of the sun, and then allow it to, as it transpires, or I guess that transpiration, right? When it dissipates, then warms up the area and allows you to grow fruit trees or herbs that you might not be able to grow in that particular climate.
Just raising the humidity.
What is it?
Raising the humidity immediately adjacent to the pond, and the thermal action of the pond helps give you that microclimate.
All right, I got one more example I want to give y'all, and this is something y'all can do here. Compost pile. Y'all been talking about compost a little bit. Taking your food waste, organic material from trimming of your shrubbery and things of that nature, and storing it, making a pile out of it. Can anybody think at least three reasons why a compost pile would be a good thing to have. Recycle waste.
Natural fertilizer.
Natural fertilizer, that's a great one.
Organic matter to the soil.
Yeah, you feed the plants plant food.
It's pretty hot.
Well, it'll cook. Cooks off.
Yeah, you could actually,
Pipe
methane
it.
digesters, they take, and it puts off so much heat, you can run a stove in a house off of it, Worm pile. Not only do the worms eat up the organic material, but they also excrete the waste, which is rich, nutrient-filled material.
The X factor of 10 when it goes through the worm.
Oh yeah. It's really, really good stuff.
Worm in your food, you use the worms in your pond for the fish.
Exactly. Fish food, nutrient builder. They also,
Soil aerator.
soil aerator. Also attract different forms of wildlife, lizards, birds.
Didn't you say you could use that as a mulch, Bob? Didn't you say you could use that as a mulch?
Compost,
Yeah.
you can. I mean, mostly it's more like a side dress type thing. It's more like a fertilizer, but
Side dress of the mulch on concrete.
the mulch is composting in place, so it's part of it.
Okay, here's another structure, another reason, function. Say you build your compost pile, you enclose it, you use the walls to grow fruiting vines up on the wall as a trellis or arbor or for fruits. Vaughn's a mushroom specialist. Have y'all ever heard of compost tea?
Yeah.
Okay, well that's another good thing. That's liquid fertilizer.
Just take the
Horse giant tea bag and just soak
take the thirds of horse shit, wrap them in a t-shirt, dip them in a 5-gallon bucket, and have the irrigation system go with your water hose, drip it along the line around the house.
It's like Miracle Grow.
Yeah, like Miracle Grow. Compost.
Except you don't have to go buy it. You can make it. And
Healthy to eat.
sir,
And the plants treated Miracle Grow healthy to eat.
I don't like that stuff.
There's no scientific evidence to show that they're particularly unhealthy, but there's good circumstantial evidence in the garden that a good organic garden has healthier plants in general. And there's some studies that show that when it's grown well with full nutrient load, then you're getting more nutrients out of it. Whereas Miracle Grow is giving it just the N, the P, and the K, the nitrogen, the potassium, and the phosphorus, and nitrogen, phosphorus, potassium. And that's just not everything that plants need to grow well, and it's not everything we need to grow well. So in a well-managed organic garden, your nutrient profile is going to be much more diverse than if you're just feeding Miracle Grow. A good example of that is hydroponics. You can't just give Miracle Grow to a hydroponic system. The plants will not survive. They're living on water. You have to have their full nutrient profile available in the hydroponic system for it to work.
so that's a good point. We're talking about manufactured industrial goods and the setbacks of using those elements. If you go buy a bag of fertilizer, Scott's Bonus or 10-10-10 or any kind of fertilizer from the hardware store or a chemical company, if you look at the bag, it says 99.9% inactive ingredients. Okay, so that means like 0.1% is actually the active ingredients. The rest of it is just filler that they use, which is waste from the industrial process. So they just figure out how to package it, sell it to you, so you can then go put it on your garden and grow some toxic veggies, you know? Radioactive fruits, you know, I mean,
Figure out a
it's,
way to measure it out where it's not harmful itself.
The fact is, we don't need that stuff because we can grow it, or we can select plants or materials that have the nutrients in it that we need from an organic or natural source. Even mined sources are better than extracting the nutrients you need from oil. You know, mined bulk materials are going to be less impacted than all the chemicals you're getting produced in the by process of turning it into fertilizer or bombs or whatever else you're going to do with it.
yeah, you know, the petroleum industry's tied into everything. Plastic bags are made out of petroleum, you know, plastic bottles, a lot of just everything is a byproduct of that. But anyway, that's about it. Do y'all have any questions regarding these things? Yes, sir.
I do. When you're talking about your straw bale houses and your cordwood homes, what is the lifespan of one of those houses? Do you have to treat the straw bales or the cordwood, or do you leave it just natural?
You leave it natural, and you're going to have to do maintenance on a natural house. You're going to have to do maintenance on a manufactured home. But again, it's much easier to go out and mix up a batch of cob, reapply it to certain areas that are deficient on the wall, keep it sealed nice and tight, and keep the bugs and the water out. If the straw bales get wet, they could start to mildew, break down. You have a problem, but it's not anything major. You just deconstruct that section and fix it.